Beneath a quiet stretch of New Zealand countryside, sheep graze on rolling green hills. Steam drifts lazily from distant hot springs. Tourists snap photos of turquoise lakes without a second thought. Nothing here suggests violence. Nothing here suggests that this exact ground, once tore itself apart. Because 350,000 years ago, this landscape did not exist in the form we know today. It was erased, buried under debris so thick it swallowed hills whole, rewritten in a matter of hours by one of the most violent explosions our planet has ever produced. Scientists have just finished reconstructing exactly what happened that day. And what they found wasn't a single eruption. It was many, firing almost simultaneously, from sources no one knew were connected. To understand what happened, you first need to understand where. Beneath New Zealand's North Island lies the Taupo volcanic zone, a 200-mile stretch of restless earth and one of the most active volcanic regions on the planet. Most visitors never realize they're walking on top of a furnace. Lake Taupo itself, so calm, so photogenic, sits inside a crater carved out by an eruption so immense it barely fits inside human imagination, because no human witnessed it. This region doesn't erupt the way a classic mountain spits lava down its slopes. It erupts the way the ground itself gives way, cracking open across a wide area rather than a single peak. And of all its ancient outbursts, one event stood apart in both scale and mystery: the Whakamaru eruption. Picture the scene, reconstructed now from layer upon layer of hardened ash and rock. Deep underground, molten rock had been gathering for tens of thousands of years, pooling into a reservoir under immense building pressure. At some point, the crust simply could not hold any longer. The eruption didn't begin with a single crack. It began with a rupture, as though the Earth's skin had torn open in several places within moments of each other. Scorching clouds of gas, ash, and pulverized rock, known as pyroclastic flows, raced outward faster than any land animal could ever hope to escape, hugging the terrain and flattening everything in their path. Behind them came a rain of ash so thick, so relentless, that it didn't just cover the region, it buried it, in some places under hundreds of feet of debris. For years, geologists believed an eruption of this magnitude had to come from one place, a single, enormous magma chamber, discharging itself in one cataclysmic pulse. It was the simplest explanation for the most complicated destruction imaginable. But new evidence has completely overturned that theory. By analyzing the chemical fingerprints trapped inside ancient ash deposits, comparing subtle differences in mineral composition, layer by layer, site by site across the region, researchers found something they weren't expecting to see. The ash wasn't uniform. Its chemistry shifted in ways a single source simply couldn't produce. Instead, it now appears that Whakamaru was fed by several magma reservoirs, sitting at different depths beneath the crust, erupting in rapid, overlapping succession. Not one furnace, but a network of them, acting almost as a single organism. Think of it less like one dam bursting all at once, and more like an entire chain of dams failing within hours of each other, each collapse adding more force to a flood that was already unstoppable. This discovery changes how scientists think about the anatomy of a supereruption altogether. It may not always be one monstrous chamber lying in wait beneath us. It can be a hidden, interconnected system, quietly linking pockets of molten rock across miles of crust, patiently waiting for the right conditions to unleash everything at once. When the ash finally settled, New Zealand's North Island was unrecognizable. Valleys were filled in completely. Rivers were forced into entirely new paths. An area larger than some small countries had been reshaped within the span of a single catastrophic event. Over the following hundreds of thousands of years, wind, rain, and time slowly sculpted that same ash and shattered rock into the hills, lakes, and plains that define the region today. In a strange, almost poetic way, the volcano's violence built the very land that later generations would come to call home. It's a quiet reminder that some of the most peaceful-looking places on Earth were forged inside total chaos. Naturally, a discovery like this raises the question that always follows stories like this one. Could something like it happen again? And if a hidden multi-source system like this existed beneath New Zealand, without anyone realizing, what does that mean for the supervolcano most people have actually heard of? Yellowstone. Yellowstone sits atop a colossal underground reservoir of magma in the western United States, and its past eruptions were large enough to blanket much of North America in ash. It's easy, understandably, to let the imagination run wild here. But scientists who monitor Yellowstone around the clock, tracking ground deformation, gas emissions, and seismic activity, continue to find no signs that a major eruption is anywhere close. The system beneath it does show signs of life, slow and constant, the way a sleeping giant breathes in its sleep. But being active and being on the verge of erupting are two very different things, separated by a gap far wider than headlines tend to suggest. What events like Whakamaru actually teach us isn't a countdown to the next disaster. It's a lesson in complexity. These systems are not simple, single-point weaknesses. They are layered, interconnected, and capable of behaving in ways scientists are only now beginning to fully map. Understanding the eruptions of the deep past gives researchers sharper tools to recognize warning signs earlier, whenever and wherever the next major event occurs, whether that's decades away or thousands of years down the line. Stand on the shores of Lake Taupo today, and you would never guess what lies beneath your feet. The water is calm. The hills are a soft, endless green. Life goes on exactly as it has for generations, undisturbed and unaware. But somewhere far below, the same forces that reshaped an entire country 350,000 years ago are still there, patient, powerful, quietly rewriting what we thought we understood about the ground beneath us. Because supervolcanoes, it turns out, don't follow a single blueprint. Whakamaru proved that a catastrophe of this scale doesn't need one dramatic trigger, one singular flaw in the Earth's crust. It can be built from many smaller failures, compounding and feeding into each other, until an entire region is transformed in the space of a single day. And that's the unsettling elegance hidden inside this story. The Earth doesn't need one enormous weakness to change the world forever. Sometimes it only needs several small ones, aligning at exactly the same moment. Geologists studying the Taupo volcanic zone today aren't only looking backward into the past. They're using what they've learned from Whakamaru to reinterpret the warning signs of other active systems around the globe, comparing eruption timelines, chamber depths, and seismic patterns from the Pacific all the way to the western United States. Every single layer of ash pulled from the New Zealand soil adds one more piece to a puzzle researchers have been quietly assembling for decades. Because whether the system in question is Taupo or Yellowstone, the underlying questions remain exactly the same. How many hidden reservoirs actually lie beneath the surface? How connected are they to one another? And how much warning would we truly have before they began to move? For now, the answer is a reassuring one, even if it isn't the final word. No eruption is on the horizon at either site. What we have instead is knowledge, hard-won from ash that fell hundreds of thousands of years ago, telling us more about our planet's hidden machinery than we have ever known before. The ground beneath New Zealand is quiet now, calm, green, and utterly ordinary to look at, but it hasn't forgotten what it's capable of. And thanks to this new research, neither will we.